So now we are doing a new lesson. It's 2.3. It's about how to classify functions. So let's start with the first property in this lesson. We are talking about one-to-one and many-to-one function. What does it mean one-to-one? What does it mean many-to-one? And how do we check that? I can check it if I don't have a graph, I just need to look at the value of y. We say one-to-one function if there is not two or more x, they have the same y. Or we can say it differently, there is no repetitive y. If there is a repetitive y, if there is two different value of x that they have the same y, we say that it's many-to-one function. Now, how we can check if it's one-to-one or many-to-one function using the horizontal line test. Now, let's see an example to understand this part. If I move to the first example here, guys, if I look here at this those coordinates, you can see easily that I have the for x equal minus 5y is 1, and for x equal to 2y is 1. So I have a repetitive y. It means it's called many to one function. If you look at this function here, I have the function of x equal 1 over x defined for all x except x not equal to 0. Sure. Is it one to one or many to one function? Here, for each x, I will have one y. I cannot have for the two different axes the same y. Not two axes will give me the same y. So it's called one-to-one function. And if I have graphically, you look at part C and part D, if you do the horizontal line test here, look how many horizontal line tests I did here. It cuts the function exactly 1 point. So I cannot have for two different x the same y. It means it's one-to-one function. But if you look at the example D, and you see the green line here, look, it cuts the function in 3 points. It means if you look at, for example, this, let's say x minus 2y is 1, x 0y is 1, x 2y is 1. So I have a repetitive y, so it's called many to one function. Let's move now to another function. It's called onto function. What does it mean, onto function? A function is onto if every element in the range is an image of an element in the domain. What does it mean? Just you need to look at the range. This is the range. And you see, does all the values of the range represent an image or are an image of a value in the domain? If you look at E is not an image of any value from the domain. It means this is not an onto function. So since E is not an image of any point or any value in the domain. So let's do some example to understand what does mean onto function. If I look at this example, first, I want to see if this example is an example of a function or not. Yeah, it's a function because for each x we have exactly one y. If I look, 1 has a y, 2 has a y, 3 has a y. If 2 has another image, it means it's not a function, it's called a relation. Is it one-to-one function? No, it's not a one-to-one function because I have a repetitive y because 2 has an image b and 3 has an image b, so it's not one-to-one function. Is it an onto function? Yes. I look at y. Do we have any value here in y that's not an image of any point from the domain? No, so it's an onto function. If I had it, for example, like here, let's say like here I have, first, if I have like this, I cannot say that's a function because this point has two, the same x has two images. So it's not a function. So I cannot continue talking about it's one-to-one or onto function. So if I have, for example, like this, and let's say here this is the point 1, here 2, 3, let's say here it's 4 and 5. Is it a function? Yes. Is it one-to-one function? Is it one-to-one function? Yes. Is it an onto function? No. Why? Because I have one doesn't have that is not any or doesn't represent any image from the domain of the finish. Let's move to the last part in this lesson. This is very easy. What does it mean even and does it mean odd function? And how do we know if it's an even or an odd function? An even function, guys, it's a function that if I replace x by minus x, it will give me the same function. So if f of minus x is equal to f of x, so we say it's an even function. And any even function is symmetric with respect to y prime or y. So if you have a graph, graphically, how I know if it's even, if it's symmetric with respect to y prime or y. An odd function, if I replace x by minus 10, it gives me its opposite. So if f of minus x is equal to minus f of x, so we say it's an opposite function. This is when I'm calculating. Now, graphically, sorry, it's an odd function. I think I said opposite. Graphically, how do you know if it's an odd function? If it's symmetric with respect to the origin. Let's do the first example. If I said f of x equals 3 minus x squared. Okay, is it even or odd? I replace x by minus x and just calculate. 3 minus x squared. So 3 minus x squared, I got the same answer, exactly the same. So it means it's an even function. If I want to graph it, this is a parabola, this is a U shape. And if I want to graph it, I will take point, the vertex is 0, 3. I just want to remove that. This is the range. Okay. If you look at it, yes, it's symmetric with respect to the y prime and y. Look, the red part is symmetric to the yellow part. And is it a many to one or one to one function? It's many to one because using the horizontal line test, I can say that it's many to one. Okay, you're gonna ask me here, is it onto function? I cannot say it like this. I need to determine for y where, because here, if the question was, is it an onto function for y less than or equal to 3? Yes, it's an onto function for y less than or equal to 3. It is an onto function because for all the values less than or equal to 3, all the y's I have an x. But if I said, is it an onto function over r? No, over r it's not an onto function because, for example, for y equal to 4, I don't have an x. Y equal to 4 is not an image of any point in the domain of definition. So when they will ask you about onto function, they should determine where I'm talking. Sometimes it's everywhere in onto function. Sometimes we need to determine on which part it's an onto function or not. You're gonna tell me, oh, okay, Miss Excellent. So all the quadratic equations are even. No, it's not all the quadratic equations are even because not all the time the y prime y is the axis of symmetry. Guys, if I have this is a parabola here, this is not an even function because it's not symmetric with respect to y prime or y. And if I give you this one, for example, y equal, let's say, x squared plus 3x plus 4, is it an even function? Because I saw 2 here, I said, no, it's not an even function because if I replace x by minus x, I will get like this. It will be x squared minus 3x plus 4, and it's not its opposite and it's not the same. So it's neither. Not because there is x squared, so I will say it's an even function. An even function should be all the time symmetric with respect to y prime or y. So the parabola should be here like this. And the not function is symmetric with respect to the origin. Let's see another function here. If I gave you this one, so I just need to calculate g of minus x, so it will be minus 3x minus x3. It's not equal to g of x, so it's not even, I'm sure. How I will check if it's odd? All the time you factorize by minus 1. So it's minus factor of 3x plus x squared. Is it minus g of x? Yeah. So it's an odd function. If you draw it, guys, it's going to be like a snake. And you can see that this part here is symmetric with respect to the other part here with respect to the origin. So those two parts are symmetric with respect to the origin. Oh, is it a one-to-one function? Yes, because if you do the horizontal line test, it will cut it in exactly 1 point. The last example, and you know this, also we saw it in the preceding lesson, 2.2, the piecewise function. It's a piecewise function because there is a piece over an interval and there is another piece over another interval. If I do g of minus x on the first part here, so I can see that it's not equal to g of x, neither minus g of x. It means that no need to continue even on the second part. So this function is neither. It's not even and also not odd. That's it for this lesson. It's a very easy lesson. So it's just 3 objective, 1-to-1 or many-to-1, onto function, even and odd, and that's it. See you next time in the second video.